I'm Anil Kumar, and now let us explore equivalent linear systems. The question here is, explain how you can write equivalent linear systems with solution as -1, 3. So that is to say, -1 and 1, 2, 3, that our linear system should have this point as solution. So the best and the easiest way of writing an equation for the given solution is that we can always write x equals to -1 and y equals to 3. Now these represents a linear system. X equals to -1 will be a straight line with x value of -1, right? So that is a vertical line right there. Okay, so that is x equals to -1 and y equals to 3 means a horizontal line going through 3, right? So this forms a basic set of linear system with solution of -1, 3. Do you get the point? So that is a neat way of writing a linear system. Now let us see how to make equivalent linear systems. So from our learnings, what we will do is we can add the equations or we can subtract, right? When you do that, you get equivalent linear system. If I add these two, what do I get? Let me use a different thing. If I add, I get x plus y equals to, when I add this, I get 2. And when I subtract, I get x minus y equals to -4. Now we have to see if that forms a linear system with this solution. Okay, let us check. If I write -1 for x, -1, and 3 for y, -1 plus 3 is 2. So that point lies on this line. Now, if I write -1 in the second equation, -3, I do get -4. It works, correct? That means this set of equation forms an equivalent linear system. Do you see that? Well, that's great. So what we can also do is at times we can multiply them by numbers, right? Let us call this as equation 1, this as equation 2, and now this time what I will do is I'll multiply equation 1 by 2 and then add equation 2, right? And I will do this time equation 1 plus 2 times equation 2, okay, and form a new system, right? So if I do 2 times x, I get 2x, and here I get minus 2, right? So and plus, so 2 times the first equation is 2x and plus y. I'm just adding the second equation as such. And on the right side, I get 2 times -1, which is -2, plus 3 is +1, correct? That is what I get when I multiply this equation by 2 and the other one add as such, right? So that is my new system of equation. And when I do equation 1, let me write this as equation 1, which is x equals to -1 plus 2 times this one. Then on the left side I get x plus 2y, and on the right side I get -1, 2 times 3, let me write -1, plus 6, that gives me 5. So I have a linear system now. Now I have to check whether this satisfies the point -1, 3 or not, okay? So let us substitute -1 and 3. What do we get? 2 times -1 plus 3, right? 2 times -1 is -2 plus 3 is indeed 1, so that works, correct? Now here also, for x, let me write -1. So if I write -1 for x plus 2 times 3, I get -1 plus 6, which is also 5, correct? So it works. So what we have learned here is that you can multiply your equations, add or subtract them, and you get the same set of equivalent linear systems. This is what we are learning here, right? So this time what we will do is we'll multiply the equation, first equation by 3 and add equation 2, And then what we will do is we will just have equation 1 and add 3 times equation 2. Let us say like this, right? Now 3 times equation 1 means 3x equals to minus 3, and equation 2, if I add to this, I get plus y here and plus 3 there, right? So what I get now is that 3x plus y is 0, right? So I get 3x plus y equals to 0. That is one of the equation. The other one, first equation as such, that means x equals to minus 1. And to the second equation, I have to multiply by 3 and then add. So 3 times y, and 3 times 3 is 9, so plus 9. So I get x plus 3y equals to 8. Now I got this set of equations. We have to check if point minus 1, 3 is on this line or not. Let us verify it, okay? If I write minus 1 for x, I get what? 3 times minus 1, y is 3. That means it is minus 3 plus 3, which is indeed 0. So it satisfies. Now in the second equation, minus 1 plus 3 times 3, we get minus 1 plus 9, which is indeed 8. So the point lies on this set of equation also, correct? So you see, we have created from the original point so many different sets of equations which form equivalent linear system, and these are all equivalent linear systems since the solution of these systems is the same, which is the given point. I hope you appreciate how to form equivalent linear systems for a given solution. I'm Anil Kumar. You can subscribe to my videos and learn more about linear systems. Thank you.